Yeah, okay, good. So, everybody ready? This is conditional probability, and so you took notes on a brand new thing today. Why do they keep putting statistics into other classes, like geometry or algebra? In my algebra class, there's a whole statistics section. Okay, the reason is because probability and statistics is highly applicable to almost everything you guys are going into. So here's an example. I went to engineering school. I took a probability and statistics for engineers. Then I went to business school. I took a probability and statistics for business majors. And then I went to education school and I took a probability and statistics for educators. Are you following me? In each of those areas you have data, and data is everywhere now because we live in such a large world with so many people, that now you're crunching data. No matter what profession you go into, you're probably thinking about prob and stats, probability and statistics in that major. All right, so today's is conditional probability, and I'm gonna do just a brief overview of this and run you through some of the ideas involved. I put it up on the board first because it takes me so long to write all this that I can't do it very quickly, right? So everybody say probability.
Probability.
What is probability? If I say to you, and this might answer it for you, if I say to you in context, what's the probability it's going to rain today? The chance. And if you had to answer numerically, even thinking about rain, what's the probability it's going to rain today? What might you say? 0%. Did you hear that? So you guys already have an intuitive understanding of the way probability works. It's a percentage. Doctor, yes, she's on her way. Bye. Okay, so think about that. Now tell me what a percent is. And it might help. I don't know if this is going to help. I think it's centum, like that. Do you know what centum means? How about the word, you've heard words with cent in it, like century? How long is a century?
Per 100.
It's literally percent means per 100. And when I finally figured this out in my life, percent all of a sudden made sense to me. So if you've got 5 cars, right, that happens out of 100, it's 5% because it's 5 cars per 100 cars did something happen to. You with me? Okay, so percentum, I don't know if that helps you, but it did me. And I was embarrassed when I finally learned it. It was probably not until, I don't know when. Probably a lot later. Okay, so here's the idea. You know what probability is. It's a percent. And so if I ask you what's the percent of rain today, and you said 0%, it's a per 100 number. I could ask you a lot of probabilities, and you probably have an intuitive sense of what's going to happen when, because we're pretty good at estimating things based upon our history, right? How many get picked up after school by a parent? Okay, what's the percent probability that they're going to be on time? Okay, 20%. Give me a number. What's your number? 100%, because they're here all the time, right? What's your percent? Interesting. Okay, they're late a lot. Okay, I'm sorry about that. But you know the history, and so you're gauging it based on your experience. You with me? Okay. Permutations without repetition. So now say permutations.
Permutation.
And it's a strange word. It's got a U right in there. Perm, U, and then tations. There's this idea of without repetition. I'm going to try to explain it in a second. But what's repetition?
Repeating.
Repeating. So, okay, with that in mind, we don't know what a permutation is yet, but we know what repetition is. In this case, we're going to ignore it. So here's a case, and even the wording is strange on this. Drawing a group at a single and, man, my grammar, my English is bad, and we are concerned with order. Okay, what does this even mean? Say you have a bucket and there's marbles in the bucket. So when they're saying drawing a group, they're talking about drawing out a group of marbles. And by drawing, they mean picking them out. Okay, it's a weird word because in my mind, why you start saying drawing, and I'm thinking of drawing, right? They're drawing it out of the bucket. They're picking out a group of marbles, okay? And we are concerned about the order. So here's the situation. If 3 items are selected from a group of 8, and they're unique items. So there's 8 marbles in a bucket. And each one of the marbles is unique. What about the marble could make it unique? And don't say size because we want a random idea that we might pick one or the other. How about color? They're all a different color. You with me on that? So there's 8 marbles, all a different color, and we're going to pick out 3 from the group. We're going to draw them out from the group. How many permutations are there? So the question of permutations is, how many options are there in pulling these 3 out from the 8? So you're back to a chance of this, or how many different ways can this be done, right? So here's the formula. It looks pretty complex to me. It says NPR. There's a capital P, that stands for permutations. There's an N, that stands for the total number that we're dealing with, 8. There's R, that's the number we're drawing out. And then there's this thing, there's an exclamation point. Have you ever seen an exclamation point in math? Okay, say factorial.
Factorial.
Okay, we're going to learn something brand new. You'll use it a lot in later years, or especially in statistics, I believe, and maybe some higher level math. I'll show you that in a second. Here's the complicated formula, and I'm going to show you how to fill it in. So for example, in this one, we had 8 total items. Here's the 8 and the 8 showing up where the N is. Here's the R, the number we drew out. And here's the formula, 8 factorial divided by 8 minus 3, parentheses, factorial. And you're going to get out your calculator soon, and I want you to plug in what a factorial is. Hang on one second, because we'll do that. Before we do, because I'm worried about time, I'm going to jump into the next situation. This is a permutation with repetition. So now we're drawing a group at a single time, and we are concerned with order, and there are repeating items. Example, how many permutations are in the state name of Mississippi? Did you learn how to spell Mississippi when you were a kid? Because it's such a fun word to spell. And your teacher might have sung a tune to you. I got a nod. Do you remember it? You want to do it? So it's something like this. When you spell it, you do M-I-S-S-I-S-S-I-P-P-I. Does that sound familiar? I'm getting some no's and some yeses. Okay. Anyway, the cool thing about the word is, look at how many S's there are. 1, 2, 3, 4. Interesting, right? Look at how many I's there are. 1, 2, 3, 4. Look at how many P's there are. 1, 2. So what we have are repeating items, but we care about the order. Why do we care about the order? Because we want to spell the word Mississippi, right? It's in an order, so we care about that. So this is a special permutation, and it's got a different formula. With this one, we didn't care about the order, right? This one we do. Because we care about the order, the number of permutations might be different, right? So here's the formula, n factorial over the repeat 1 factorial. And in this case, there's 4 S's, so you get a 4 factorial down here for one of the repeating, because there's 4 of those repeating. And then there's 4 I's, so that's going to be a 4 factorial, and these are all multiplied by each other, and there's 2 P's, 2 factorial, right? The next thing, do you have your calculator out? And I apologize, I'm rushing through this, and not a good idea, but I want you to find out what a factorial is. So here's a 3 factorial. What does it mean? It means 1 times 2 times 3. What do you think 4 factorial means?
1 times 2 times 3 times 4.
Ding. What do you think 5 factorial means?
1 times 2 times 3 times 4 times 5.
And so you can imagine a 10 factorial, 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. The numbers get big quickly. Are you with me? That's what a factorial does. All right? So go to your calculator and I want you to find the factorial key because I bet you've never, potentially, you might have never used it before. So how do you calculate them? Well, 1 times 2 is 2 and 2 times 3 is 6. Fair enough? Now if you do the next one, 4, there's a 4 addition here. So 6 times 4 is going to go to 24. This one now has a 5, so 24 times 5 is going to jump to 120. And this is how it goes. So find your factorial key and see if you can type in 5 factorial and see if you can get 120. First, can you find the key? Good, thank you. And so now, Shaolin, I want you to put in something big, like put in 10 factorial, and see what kind of number it gives you. Right? Is that 3 million?
Yeah.
Now that's a big number for just 10 factorial. Are you with me? This is cool. Okay, so did you find it? Good. That's 10, right? Did you find it?
10.
Okay. Did you find your factorial?
3,000?
It's very exciting. You should go home and show some.
3 million, really?
3 million, huh?
Turn it
For
sideways.
10?
Yep.
I'm getting
And I think it's in
Oh, wait.
the-
so dumb.
I think it's right down. I think it's right there on yours.
I'm clearly not that
And
bright
yours is
on
going to be
numbers.
there. Okay, so type in a number, clear it. Type in like 5 factorial and make sure you're getting this value. If you type in 5 factorial, you should get a 120. And then try a 10 factorial and see how much that jumps up, right? Because it's
100 factorial.
yeah, what about 100
Oh, wow.
factorial,
I don't know
right?
what that is, mister. 100 factorial.
So that's an E, that's a scientific notation. It's times 10 to the 157. That's a very big number.
Oh, wow.
Okay, that's a really large number. Okay, so you know what factorials are. At least you kind of got the concept to be, we're moving fast through it. I want you to do one thing. I want you to try to do this computation. So you're going to do 8 factorial, then say divided by. Then we're going to do the math already. 8 minus 3 is 5. And it's divided by 5 factorial. And if you have an iPhone, you still have to say equals after all that. And you're trying to get 336. If you get 336, you did it. Anybody not do it? Good? Okay. My apologies for the rapid pace, but I'm going to stop right there.